In question 25a, we're asked what is meant by coherent waves. Well, coherent waves have a constant phase difference. In part B, we're asked to state with reason the motion of a particle at point x when both waves p and q are present. Well, it will oscillate in phase with particle p, but at a reduced displacement due to the destructive interference with wave q. In part C, we have a laser placed close to two slits. In part 1, we're asked to explain why the bright and dark fringes are observed on the screen. Well, where there's a whole number of wavelengths path difference, the waves will meet in phase, constructively interfere, and produce a bright fringe. Where there is an odd number of half wavelengths path difference, they meet in antiphase, destructively interfere to produce a dark fringe. In part 2, we have the laser replaced with another laser B with light of a different colour of a much greater intensity. We're given the two fringe patterns. B has a more spaced out fringe pattern. A student suggests that laser B is more spread out because of the intensity being greater. We're asked to give a correct explanation. Well, the fringe spacing x is given by lambda d over A, where lambda is the wavelength, d is the distance from the slits to the screen, and A is the slit separation. D and A have not changed, but lambda has gone up. So B has a greater lambda, greater wavelength, so greater x, x being the fringe separation. In part 3, we're told to state the effect on the pattern of light seen on the screen when one of the slits is blocked. Well, there would no longer be interference, so the bands would disappear.